Hello and welcome to another week of CAD guides. And this week we'll be going over step by step through week 7 drawings, and we'll be doing the double solenoid stand as the example. As always, you can find links to these slides in the description. So when we're doing drawings, something to keep in mind are we got to look at what other parts are interacting with this part and what kind of interactions they're having. We have to worry about the tolerancing, the reference point, and the material of the part. And we'll talk a little bit more about each of those things as we go on. So what do we want from a drawing? Well, we want it to be clear and, be very clear about what kind of points and data we're taking. And when we take dimensions of a drawing, we want to take it from the same point, which means that if I'm going to set up a part on a machine to create some holes, I want to know the distance from only one corner that each hole will be so that I don't have to keep repositioning my part around. And once you start machining, you'll know exactly what I'm talking about. Another thing we want to worry about is that we want drawings to be simple. So we don't want to create too many dimensions where we're creating redundancies. That's just not necessary. We want to be able to reference each dimension just once, and that's all we need for the part. And we need it to be robust, so that when we've created this drawing and we go back and change the part, the drawing dimensions should be able to change without breaking. And that's one of the great things about doing drawings with Inventor, is that the drawings will dynamically update with the part that they're linked to. So go ahead and go to the double solenoid stands URL, and you'll be able to download it. And don't wait for it to load a preview, because Google is unable to load previews for IPTs. So once you download it and load it up, you'll see what I'm seeing on my screen. So all you have to do to create a drawing, and this is the easiest way to do it from a part, is you go to New, and then Drawing, and then Use Template. There are always other ways to make drawings, but this is the way that I like to do it. So this drawing will be blank, and you'll see that there's this massive border and this tiny little title box. So you'll know that if you go to Edit Sheet, or you'll notice that when you go to Edit Sheet, you'll see that the sheet size is D. D paper is pretty massive. For reference, B paper is 11 inches by 17 inches. Which is kind of standard for engineers, but A is your regular printer size paper, and that's what we'll be using because that's what we print off of in the CMA, or near the CMA. So now you'll notice that this title block, even though we've changed the size of the paper, the title block is the same as it was before. So we're going to go ahead and go over here to ANSI large, and we're going to delete that. And then we'll go ahead and open up Drawing Resources and Title Blocks and double-click ANSI A. And this is a better representation and takes up much less space. Once we have this title block, then we can delete our default border because we don't need it. And to edit this title block, you can always just go to Annotate and enter text, or to do it officially, you double-click on Field Text and you'll see all this stuff. Go to this clipboard icon, and then when you go to Summary, you can change everything in here. So I'll call it double solenoid sand, and just subjects would be RoboJackets, mech training. And you can change it as much as you want. If you go into the workforce with this kind of thing, then there will be probably different standards. You might have to type in all caps, for example, or put very specific things in each of these boxes. But if you're doing this for personal reference, then this doesn't matter as much. Sometimes we'll be making drawings in order to send them out to manufacturers, and so to give them as much information as possible will probably be the best. So now we're going to start doing the drawing with its dimensions. So we'll place views to base, and because we created this sheet from the original double solenoid IPT file, it's already loaded into this file here. So you can go ahead and search for a new one if we want to create a different file, but this is the fastest way. So once we're looking at this base model, and the base will depend on the view from the IPT. So if you look at the front, then you'll see that this is the view. And in the same way, we have the same cube. So I can actually turn this if I really want to. And then you can just drag, or not drag out, but if you just hover over around this base view, then we can just left click once to create these side views. And depending on symmetry, you might be able to get away with creating only a couple of these views. For example, since it's the same on the top and the bottom, and the left and the right are the same, I could probably only place just the top and just the right. And then we can go to the top right and create this isometric view. Now when we're looking at style, we want to deselect shaded, and we'll be left with hidden line. We can also do hidden line removed, but for now we're wanting to look at hidden lines. And what that means is when I click OK, you can see that internal cuts within these shapes. So if I did, let's see here, if I go edit view and do hidden line removed, then you'll only see what you'd see from the outside. Which can be good if you're only doing a few simple things. But when it's a complex shape and we want to get easy dimensions, creating these hidden line views is the most effective. Another thing to note is if I'm looking at this edit view, I can change the scale. So if I think it's a little too small, I can make it bigger, or if I think it's too big, I can make it smaller. And as you start dimensioning things and realizing that you need either more or less space, then you can always change that. So now we're going to start dimensioning our part, and we'll go to this Annotate tab. And when we're creating dimensions, and I'll create a dimension, let's see here, on the top box, we'll just create a dimension. Actually, we'll make the one from here to the center of this circle. If I double click on this dimension, then I can edit the text. So this first couple lines will just be the code way in the computer for saying just the dimension, and I can add anything here, and you'll see that it's entered anything. And then I can go to precision and tolerance, and so if I choose that I want to do a tolerance, I can choose symmetric, and I'll do one later. We don't want to do this all the time, but when we want tolerances, we'll do symmetric. And I can change the primary unit to have different accuracy and precision, or different precision. So I'm just going to keep it at this number of significant figures, and I'll just hit OK. And so we're going to look a little bit at holes. So we have a bunch of holes in this part. So we can go to hole and thread, and we'll zoom in here and select this outer circle, outer hole, and you'll see that it instantly comes out with the hole and thread size, which is really great and very useful. However, if we're shipping this off to a manufacturer, then we'll want to be able to add a little more details for what they would be looking for. So we're going to go ahead and escape out of the hole and thread function, and we'll double click on this dimension here, and you'll see that there's a little more code for what the computer is looking for. So I'm going to go ahead and add what's called the hole depth value, and I'll add a space and hole depth value, and it'll instantly come out with this code here. And then for the symbol, I can click this drop down and find the symbol that I'm looking for. So I just have to match the symbol that's here on this side. So it's this little drop down symbol. As soon as I hit OK, you'll see that it is automatically put in this dimension value and then the symbol that I input as well. Another one that you might want to use is the diameter. Diameter might automatically come out It depends on what you use. So we'll go ahead and hit OK. And we'll go ahead and do a few different dimensions. So I'll go ahead and click through this. Now if I wanted this dimension here, I just have to hover over in this direction, but since I want this dimension, and let's say I'm creating this third dimension over here and I decide, it's a little too close to my main part. I might need more space later. I can go ahead and just click and drag this view up or down, and it'll automatically move every dimension that's attached to it as if they're all glued together. And then to move this leader, it's called a leader, not an arrow. You can just click any of these 3 green points and it'll move it however you want it to. So I'll put this one here. And then I'm going to create another hole and thread on the inner circle. And do the exact same thing. That end here. I'll line these up a little better. And you just want to be very clear about where these leaders are pointing to. The more information you can give to your manufacturer, the better, as I always say. Now you can go to text here and we can click and drag, open a text box. And we'll go ahead and put holes are the same on the top and the bottom. And what that does is that says that when this machinist is looking at this drawing, if they're wondering if this bottom part is going to be the same or different, instead of having to dimension down here as well, we can just leave them a note and they'll know exactly what we're talking about. We want to be very clear, as we've stated earlier. And so we'll add one more dimension. And we'll do the height all the way over here. We're going to add some more dimensions. And something to note. This is not in the slide, but it's something I just want to point out. When you're doing dimensions with circles and parallel lines, like a hole from the side, if you don't want to try and position your dimension from like these very specific points, something you can do is you can, let's see here, you can go over here to center mark. And what this does is when you click on a circle, it'll automatically place this plus sign on each one. So some engineering firms or machinists will really like if you do this. It makes it much easier to know and dimension. And then, like I said, for holes from the side, you go over here to Centerline Bisector. And all that means is that when you click 2 lines, it'll create a center line in the middle, as if you're cutting in half, bisect. So we can go ahead and do that. And I won't do it on all of them. It's not necessary. Some people really like it. Some people don't really care. So we'll go ahead and dimension. And you'll see that it's way easier to create this dimension here. I'm just telling you the way that I learned it so that you're aware that there are multiple ways of doing things. We'll create this here. And you'll notice that actually in the slides, it's a little incorrect. And I'm not meaning incorrect like wrong, I'm just meaning that if you look closely, there's a 1-inch width dimension here, and I've accidentally created one on this base part as well. And because of the way these views are, we already know that this is 1 inch. So if one says 1 inch, you don't need it on the other. And that's what I was saying earlier about things being redundant. And we'll go ahead and put this 0.25 over here. Now you may be wondering, does it really matter where all these dimensions are going? And the answer is kind of. We want to keep our dimensions on as few views as possible. And that's because, if you're trying to machine a part and you want to know exactly all these dimensions, it's way easier just to focus in on one part rather than trying to remember where you put different dimensions. And if you'll notice, if you look closely, you'll see that all these dimensions are always from the same point. So if I'm trying to measure out how far this hole is from my zeroed point, I'll instantly know. And again, you can go ahead and change the dimension values, or the dimension precision. If I escape out of everything and right click, I can click Edit Dimension Style and edit all of them at once instead of trying to select each one at the same time. So if I do that and save and close, you'll see that all of these change. Of course, I don't want all of them at 4 decimal places. So we'll go ahead and edit it back. You'll see you can also edit trailing zeros, leading zeros, all that stuff, for all your precision needs. So there's just a couple more dimensions that we need to make. So we'll go ahead and hole and thread on this hole here. And you'll see it's automatically placed in the symbols and digits that I want. This isn't something that I pre-set up. This actually just happened on its own. And if you don't know what these symbols mean, you can always just double click and then hover over that symbol, and you'll see that that's talking about the Counterbore spot face diameter value. And that means that when we look at these two circles, they're actually not two separate holes, it's a Counterbore, which is a very specific type of, a very specific type of hole. And that's what ends up with this wider diameter over the smaller one. And so if I tried to do a hole and thread on the outer hole, then you'll see the exact same thing. So it's not necessary to put more than one, because this symbol here takes care of both of them. So we'll just add one more that's pretty important. We'll add this dimension here, and you'll see it's 0.13. But because things are very specific and we want to make sure they're as precise as possible, we're going to add in this tolerance value. And we'll make it 3 decimal places. And we can make the upper 0.005. And one more thing I forgot is the primary tolerance. Since it's 3 decimal values, we have to change that too. So that way we know that what matters more is not the 0.125 value, it's that it's got to be in the center. And because of this note up here, the same goes for the top. So with all of these dimensions, that should be enough for the manufacturer to know everything he needs to know. And this isometric view up here, you don't ever put dimensions up here. This is just as a reference for what the part will look like. And the diagonal isometric view allows to have as many faces visible as possible. And this helps you see that it's more than just a couple holes here. It's a very good view of what it might look like in real life. For some people, they like to see that it's shaded. But again, that's up to you. So once you're done with this sheet, you can go ahead and save this. And since DWG, which is what this is going to save as, isn't a universal thing, not everyone can open it, since it's particular to Autodesk Inventor, we're going to save as a PDF. And I did this wrong. We're going to go to File and Export, not Save As. You do want to save your drawing every time you want to save it, but if we're going to send this to someone, we need to export as a PDF. And you can go ahead and save that and then send it away. So remember, the important things to know are that you want to create as many details as possible without going overboard and creating redundancies. So you want to create as many things as possible on the same view and from the same corner. So with that, now we're going to talk a little bit about making Dxfs. So Dxf is another file format that's two-dimensional, and this is what we use when we want to use the water jet. So we're going to be very careful with how we do this, because if we include too many lines, the water jet will interpret them as cut lines, and we'll end up with a part that has way more cuts than we want. So the beginning of this is going to be the exact same thing as what we did for the first drawing. And again, actually, the sheet size doesn't matter as much. What does matter is that we get rid of the default border and this title block. We just want to place the base, and it has to be a 1-to-1 scale. It can't be any bigger. And we just want to place the single view here, and we want to make sure that it doesn't have hidden lines. So make sure that you go through and remove those hidden lines, as I just did. So as I did before, we deleted our border and we deleted our table. And it looks really sad right here, just this single little part. But that's okay, that's exactly what we want, is just a single isolated thing. And depending on how big your thing is, it may fill up this space a little more. But this solenoid stand, it's pretty small. So now we're going to save copy as, and it has to be copy, because that way we can go in and we'll see more file formats. If you notice earlier when I was saving as, it could only be a DWG or an IDW. But when we save a copy as, we can go to Dxf. And as soon as that's done, you can click save, and that's all you have to do. Once you click save, you can save it to a thumb drive, which you can then take over to the water jet. And from there, hopefully you'll know exactly what to do with the water jet, because you'll be trained on it. And if you don't know, just ask someone on your team who you know has used it before, and they'll be happy to help you out. So I hope you guys learned something about creating drawings, and we'll see you next week.